In this video lecture, we're going to discuss finite automata. So let's define first again what is automata. This is a theoretical machine, okay? And this machine or mechanism that is relative self-operating. So automata means automation. There is a rule that will process automatically the input, okay? So if say automaton, this is the singular version of automata, one machine. If we're talking about lot of machines rather, so we call it automata. It's the plural term. Okay. We have two types of finite state automata. We have FA with output and FA without output. If say FA with output, the current state and the current input defines the output. Okay. So we have two examples, Moore and Mealy. While FA without output, the result is defined by the string. Okay, will it be rejected or not? So we have three types. We have DFA, NFA, epsilon NFA. So what is DFA? Deterministic finite automata. NFA, non-deterministic finite automata. And epsilon NFA is basically an extended version of NFA, wherein it will include epsilon as an input. Okay. So in this video lecture, we're going to focus more on the DFA, deterministic finite automata. So what is DFA? It's the simplest model of computation. So basically, each symbol in a string will be processed. Okay, it will define which state will it go to. Okay, and DFA has a very limited memory or none at all. Since we are just storing the string, defining where will it go to the next, where will it go, or next hop, okay, next state after encountering this input, okay. And also for each input symbol, again, this will define what path to take, what state, what next state to go to. Okay. And we are using parsing to determine where to go to. So this is an example of a DFA. Okay. So we have the symbol, letters, loop, direction. Okay. So what does it mean? So an arrow going to a circle, okay, it means this is our initial state. The circle are states. A, C, and B are states. But what is the difference between A, B? We have two circles here. It means this is the final state. If the string stop with B, that string is accepted, valid to that automaton. Okay. While if it goes to C, what can you say about this C? Any values after B, okay, in our string, it will just loop back to C. This type of state, we call it a trap state or a dead state, wherein if we go to a trap state, it will not go anywhere. It will just be on that state. Okay. And by the way, this A, B are the alphabets accepted by the automaton. And again, this loop, it means it will just go within that state. And this arrow determines the path to take when we encounter this kind of inputs. Okay. So if we have A, so if A encounters A, it will go to B. If A encounters B, it will go to C. While in B, any values will just loop within the final state. For C, any value of AB will loop within C. Okay? And also, DFA could be represented by 5 tuple or 5 characters of 5 criteria. Okay? So we have Q, epsilon, delta, Q0, and F. So what does it mean? Q means set of all states on our automaton. So in this example, we have 3 ABC. So this will be our Q. While for sigma, it defines the alphabet. What are the alphabet accepted by this automaton? A, B. So this will be our sigma. While for Q sub 0, it defines the initial state. Initial state, arrow going to a state. Okay, so that will be our Q sub 0, which is A. And F means final state, double circle, which is B. And while for the delta, we're talking about the transition between these sets. Okay, so it is represented by a table. Okay, so this is the transition function or the delta. Okay, so that's an example of a DFA, simple DFA, and the transition table or transition function. So in the next video lecture, more about DFA. Okay, so thank you for listening. See you in the next video lecture.